Hello everyone, welcome to opsbyyash. You have probably heard the words Docker image and Docker container every time. But what's the actual difference? Is an image the same thing as a container? If I download an image, do I already have a container? And why does Docker need both? Let's clear this up once for all. By the end of this video, you will understand what an image is, what a container is, what happens when you run an image, and where your application data actually lives. Let's start with Docker image. The easiest way to understand an image is to think of it as a package containing everything your application needs to run. Imagine you have a Python application. Your application needs Python, some libraries, your application code, configuration, a file system with the required files. Instead of manually installing all of this every time, we package it into a Docker image. So the image becomes a ready to use package for our application. You can create an image yourself using a Docker file or download an existing image from a registry such as Docker Hub. For example, Nginx, Python, Node. These are examples of images you can use as the starting point of the container. And an important thing to remember, the image itself doesn't run your application. It's the package that Docker uses to create the environment in which your application will run. So what's actually inside this package? A Docker image is made up of layers. For example, you might have a base file system, then Python or Node.js, then application dependencies, and finally your code. Each layer represents changes adding during the image build. Now let's talk about something beginners often get confused about. If the image is read-only, what happens when the application changes something? When Docker creates a container from an image, the container gets a writable layer on the top of image layers. So if your application creates a file or modifies something inside the container, that change goes into the container's writable layer. But there is an important catch. You generally should not rely on this writable layer for important permanent data. For data that needs to survive independently of the container, Docker provides volumes and bind mounts. This is especially important for things like database, because if your database says, "Congratulations, all your data is inside this container," you don't want Docker to reply, "Cool, delete the container." Yes, and suddenly your weekend is ruined. So let's put everything together. A Docker image is a packaged read-only template containing your application and its dependencies. A Docker container is an isolated runtime environment created from that image where the application actually runs. You can build or pull an image, create and run a container from that image. An image can be used to create multiple containers, and containers can have their own runtime configuration, networking, writable layers, and attached storage. So Docker image is packaged application environment and Docker container is the running instance created from that image. But now we have another question. Once we create a container, what happens to it? Does it start immediately? What happens when it stops? Can we restart it? When does Docker remove it? That's exactly what we will cover in the next video, Docker Container Lifecycle. So if you are following the Docker Fundamental series, subscribe and continue the journey.